pulley system here, body A of mass 5 kilograms. Okay, so its weight is going to be 5g. Okay, of course there's a reaction here then, isn't it, on the surface here, but it's on a smooth surface, all right, which means there's no friction opposing it. Okay, so it can slide along nicely. And then you've got the object B here, which is of mass 9 kilograms, so its weight is 9g. Of course, then you've got tension in the string, haven't you? Okay, the string is taut, it's holding up B here, and the tension then is sort of in that string there, pulling at A. Okay, so it says initially the system's at rest, and then a horizontal force of magnitude 126 newtons is applied to A in the direction PA, so that B is raised. So, you know, if it was as it is, okay, this system would go that way, wouldn't it? Okay, the object B would come down due to gravity, and it would drag that across. But what they're saying is, right, there's a force now applied in the direction PA, okay, parallel to that way. So it's as if it's pushing it, or pulling this, if you like, this way, okay, and what is it, magnitude 126 newtons, so that it's actually raised. So we're actually accelerating this way, okay, and the string is going that way then, at A. Okay, so they want the magnitude of the acceleration and tension in the string. So if we use Newton's second law, okay, first of all at A, okay, and using Newton's second law along the string, okay, in direction of motion. Now at A, 126 is pulling it along. That's the force pulling it along, but then there's the tension in the string holding it back. So the resultant force is that, equals then to, so that's the resultant force, equals to mass, which is 5 kilograms, times the acceleration. And at B then, the tension in the string is pulling up B. Take away then the weight, which is 9g, so that's the resultant force, T, take away 9g, equals then to mass, which is 9 times acceleration. So we've got here 1 and 2. All right. So two equations they're set up. We can solve them simultaneously, and we can always just add these. If you add them, the t's will cancel, right? Minus t, add t, cancels. So you've got 126 then. Add this, which is, so because there's a minus there, so it'll be minus 9 times 9.8 for g, and then add them, you get 14a. So all you've got to do then is 126, take away 9 times 9.8, okay, which comes out to be 37.8. equals 14a, and then 37.8 divided by 14 will give me a. So a turns out to be 2.7 meters per second squared. Sub it in then to say 1 or 2, put it into 2 I think, sub into 2 to get the tension. So into 2 you've got t, take away 9 times 9.8 equals 9 times 2.7. So you can get your t then, but taking that over to the side. And we get our answer to be 112.5 newtons.